This video will present solutions to the VCE 2023 Mathematical Methods Written Examination 2, Section A, questions 11 to 15. Question 11 asks for the gradient of this product function at the point where x equals minus 2. Instead of giving us the functions f of x and g of x, we are given function values and derivative values for f and g at the point where x equals minus 2. These are the components required to find the gradient of the product function using the product rule. Into this rule we can substitute the values given and simplify to see that the answer is 10, which is answer E. Question 12 asks about the maximum possible value for the mean of the discrete random variable x with this probability information provided. Looking at this table, we can see that the mean of x, which will be found by summing each possible x value multiplied by its probability, will be a quadratic function in terms of k. There are many ways to find the maximum of a quadratic function. One efficient one is using ClassPad's fmax command, which will save us some simplification and allow us to consider only values of k greater than or equal to 0. I'm going to enter the expression for the mean of x first. Now I'll select this expression and from the interactive menu open Calculation and choose fmax. Make sure you change the variable to k and set the start value to 0, as we know that k must be non-negative. This output tells us that the maximum value of the mean is 2, occurring when k equals 0, which means the answer is E. Question 13 presents an algorithm that applies Newton's method with 3 iterations of this calculation. The inputs into this calculation are f of x, the derivative of f of x, f dashed, and initial estimate x0. One easy way to implement this calculation is in ClassPad's main app. Enter x minus f divided by f dashed given that x equals x0. Use the Math 3 keyboard for the given that symbol. This command returns the value of 5 over 6, which is the estimate generated by Newton's method after one iteration. Pressing enter again, this command is duplicated. To edit it so that it performs the second iteration of Newton's method, all we need to do is replace the x equals 1 initial estimate with a new estimate x equals 5 over 6. Pressing execute gives us the estimate after 2 iterations. Repeating this process once more will give us the estimate after 3 iterations as required. If we convert this third output to decimal form, we can see that it is closest to 0.81773, which is answer C. Whilst this method was relatively quick due to the small number of iterations required, these sorts of calculations can also be performed in ClassPad's Sequence app, which is an excellent choice, especially when the number of iterations is larger. The Sequence app is located in the second screen of apps on my ClassPad. This question can be done using the default settings of this app. The main one to check is the type of recursion, which can be checked by tapping the Type menu. In the Sequence app, we will enter the Newton's method calculation as an iterative function an plus 1, with an in the place of x. An can be found and entered from the n, an menu. Pressing execute moves us to entering x0, which is 1 in this case. Tapping the table icon on the left-hand side of the toolbar, we obtain the first 5 iterations of Newton's method, more than enough for this question. If more are required, however, we could tap the table settings icon to change this setting. From this output, it looks like the answer is C, but to check that 5th decimal place, tap on the output of interest, and it will be expressed to 15 decimal places at the bottom of ClassPad's screen, so the answer definitely is C. Question 14 can be answered from a sketch of this quartic polynomial. Given its factored form, we can see that it has roots of 0, a third, -3 and -1. Given its positive leading coefficient, this quartic will look something like this. Another way to get this graphical information is using ClassPad's Graph and Table app. Entering the function we are given, and graphing it on the default view window, we get the information we need. The question we are asked is how many tangents to this curve will pass through its positive x-intercept. Moving from left to right, we can imagine that just to the right of the polynomial's first local minimum, there will be a tangent that passes through this point. Moving further right, we can imagine that just to the right of the polynomial's local maximum, there will be a second tangent that passes through this point. Moving further right still, we get to the x-intercept in question. The tangent drawn at this point will pass through that point, obviously, so that's our third tangent. Based on this thinking, the answer is D, 3 tangents. Question 15 asks us to match one of these 5 diagrams to distributions x and y. As the mean of x is greater than the mean of y, the peak of the dotted curve will lie to the right of the peak of the solid curve, and so we can eliminate options B and E. As the standard deviation of x is greater than the standard deviation of y, the dotted curve will appear wider than the solid curve, which is only the case in diagram A.